Digital radiography is one of three methods used by radiographers to acquire diagnostic medical images. In digital radiography, we use one of three different types of flat panels. Those different panels get subdivided into one of two categories. The first are indirect flat panels, and the second is a direct flat panel. The major difference between the two categories is the use or non-use of a scintillating layer. Indirect panels use a scintillation layer. A scintillation layer converts X-rays into visible light. The two types of indirect flat panels are a thin flat panel transistor and a charge-coupled device. Both indirect flat panels are made up of three different elements: the capture element, the coupling element, and the collection element. Let's talk about the first type of indirect flat panels, the thin flat panel transistors, aka a TFT panel. In the TFT panel, the capture element is the scintillating layer, which converts X-rays into light. This scintillating layer can either be made with cesium iodide or gadolinium oxysulfide. Cesium iodide is grown in long, thin crystals, which prevents light from spreading out. This provides better spatial resolution, but at an increased cost. Gadolinium oxysulfide is cheaper to produce because the scintillating layer is not grown in crystalline structures, but it has lower spatial resolution because it does not control the spread of light. The next element is a coupling element. The coupling element uses a photodiode substance to convert light into electrons. The photodiode substance used is amorphous silicone. The last element is the collection element. The collection element collects those electrons from the coupling element on a thin film transistor, aka a TFT. Let's move from a side view of the TFT to a bird's eye view of the TFT. A TFT consists of a storage capacitor which holds the electrons given off from the photodiode, and a transistor which acts as a gatekeeper to release the electrons in the storage capacitor to a computer to process into a diagnostic image. An important consideration is the fill factor, or the amount of amorphous silicone on the TFT panel. The more surface area there is of amorphous silicone, the higher the spatial resolution. The second type of indirect panel is the charge-coupled device, aka a CCD, which is also made up of the same three elements: the capture element, the coupling element, and the collection element. The capture element is the scintillating layer which converts X-rays into light. This scintillating layer is made of a different compound than the TFT scintillating layer. In the charge-coupled device, it is cesium iodide. The coupling element is a series of fiber optic cables which connect the scintillating layer to the collection element. The collection element takes the light from the scintillation layer that traveled through the fiber optic cables to a device called a charge-coupled device. This device simultaneously converts the light into an electrical signal that is then processed by a computer into a diagnostic image. As mentioned earlier, there are two categories of DR flat panels. We've discussed the indirect type. Now let's look at the direct type. Direct flat panels do not use the scintillation layer, so they are comprised of only two elements, a capture element and a collection element. The capture element uses the compound amorphous selenium and a semiconductor to convert X-rays directly into electrons. The collection element collects those electrons from the capture element on a TFT. The mechanism is exactly the same as with the indirect TFT. Let's look at what is happening at each stage of this direct capture panel. First, the X-rays interact with the capture element and get converted into electrons. Then the electrons go to the TFT and finally sent to the computer to be processed into a diagnostic image.